Problem 80, Quantum Mechanics. The question is, the differential cross-section for scattering by a target is given by d sigma by d omega is equal to a square plus b square cos square theta. If n is the flux of the incoming particles, the number of particles scattered per unit time is. In this problem, the differential cross-section is given. We have to find out the number of particles scattered per unit time. If we have the total cross-section sigma, then sigma times the flux of the incoming particles will give the number of particles scattered per unit time. It is given that d sigma by d omega is equal to a square plus b square cos square theta. Now what is total cross-section? It is integral 0 to pi, integral 0 to 2 pi, d sigma by d omega, sin theta d theta d phi. So in the present case, what is d sigma by d omega? This is a square plus b square cos square theta. Therefore sigma is equal to integral theta is equal to 0 to pi, integral phi is equal to 0 to 2 pi, a square plus b square cos square theta, then sin theta d theta d phi. We can write it as a square integral 0 to 2 pi d phi, integral 0 to pi sin theta d theta plus b square integral 0 to 2 pi d phi, integral 0 to pi cos square theta sin theta d theta. This is equal to a square 2 pi integral 0 to pi sin theta d theta plus b square 2 pi integral 0 to pi cos square theta sin theta d theta. Now let us evaluate the integrals. Consider first integral 0 to pi sin theta d theta. This is equal to minus cos theta within the limit 0 to pi, that is minus of minus 1 that is equal to minus 2. In the same way, let us find out what is integral 0 to pi cos square theta sin theta d theta. Take this integral as I. Let us evaluate I. For this purpose, put t is equal to cos theta, then dt is equal to minus sin theta d theta. When theta tends to 0, t tends to 1, and when theta tends to pi, t tends to minus 1. Therefore, the limit of integration is from 1 to minus 1. Therefore, I is equal to integral 1 to minus 1 t square dt with a negative sign, that is equal to minus t cube by 3 from 1 to minus 1, that is minus of, this is equal to minus 1 by 3 times minus 1 that is equal to 2 by 3. Therefore, the value of our second integral is 2 by 3. Substitute these values in the expression for sigma. We have sigma is equal to 2 pi a square into 2 plus 2 pi b square into 2 by 3. Therefore, sigma is equal to 4 pi a square plus b square divided by 3. This is the expression for the total cross-section sigma. When we multiply this total cross-section with the flux of the incoming particles, we will get the number of particles scattered per unit time. Therefore, the number of particles scattered per unit time is equal to sigma times n, that is equal to 4 pi n a square plus b square divided by 3. Therefore, from the given option, option D is the right option.